FICV and FRCV, replacing legacy Armour with modular combat platforms. Armored modernization is no longer about one tank or one troop carrier. It's about a family of vehicles that share bones, chassis, power packs, electronics, while wearing different skins for different fights. India's twin tracks point in that direction. The Future Infantry Combat Vehicle, FICV, replaces aging BMPs with a protected, networked, firepower-rich carrier for dismounts. The Future-Ready Combat Vehicle, FRCV, succeeds legacy main battle tanks with a modular, growth path platform for high-end direct fire. Together, they aim to turn armored brigades into configurable toolkits that scale from counter-infiltration to high-tempo maneuver across deserts, plains, and high plateaus. Start with the FICV's job. It must carry a full infantry section under armor, keep them alive against mines, IEDs, top attack drones, and autocannon, and then support the assault with precise, stabilized fire. A modern hull with a V-shaped or multi-layered belly, energy-absorbing seats, and spall liners addresses underbody and side blasts. Add modular applique and active protection options. Soft kill jammers against laser IR threats. Hard kill interceptors for incoming missiles, and commanders can tailor protection by sector. On top sits a two-man or unmanned turret with a 30 to 40 millimeter cannon, a coax, and twin ATGM launchers for overwatch out to several kilometers. Programmable airburst rounds clear drones and defilades. Panoramic sights and hunter-killer handoffs let the vehicle find and fix targets while troops stack for entry. The FRCV solves a different problem: credible shock and anti-armor punch with weight and logistics discipline. A modular armor architecture allows threat-based kits, lighter packages for bridges and high-altitude approaches, heavier composite NERA-ERA arrays for plains fights, a high-pressure 120-125 millimeter gun with advanced APFSDS, multi-purpose heat MPAT, and airburst HE brings flexible effects. Gun-launched ATGMs add extended reach when terrain squeezes lines of fire. Modern fire control, stabilization, meteorological inputs, auto-target tracking keeps first round hit probability high on the move. An APU enables Silent Watch, a compact, high-power density power pack with digital health monitoring, shortens field repairs, and eases swaps at forward maintenance points. Common electronics and networks make both families more than metal. A shared Vitronics backbone, vehicle management computer, high-integrity power distribution, open architecture data bus lets India plug in Indigenous sites, radios, BMS terminals, and counter-UAS kits across FICV and FRCV. Blue Force tracking and tactical data links give platoon leaders a fused picture of friendlies, suspected AT teams, UAV feeds, and fire support availability. Edge AI helps classify threats from EOIR RFQs. A mastable sensor or tethered quad on select variants pops above ridgelines to scout hull-down positions without exposing the vehicle. Mobility is mission-specific but serviceable across theaters. For deserts and plains, wide tracks and robust suspensions carry heavy kits at tempo. For mountains, weight-managed builds with tuned turbo diesels, cold start packs, and multi-stage filtration keep vehicles climbing hairpins without cooking engines or choking on dust. Transmission ratios and final drives are selected for torque at altitude. Braking and steering systems are sized for long descents with heavy loads. Amphibious capability is a trade, retained for select FICV variants where rivers and canals demand it, dropped for heavier, mine-resistant kits elsewhere. Variants turn each chassis into a family. On the FICV side, infantry carrier, IFV with heavier turret, command post, mortar carrier, engineer sapper, ambulance, reconnaissance with extended sensors, and CUAS specialist with AESA radar and soft hard kill. On the FRCV side, gun tank, bridge layer, ARV, assault breacher, and a mobile SHORAD CUAS fit that exploits the tank's power and protection. Shared hulls, reduced training loads, and spare stocks. Line-replaceable units and front-opening electronic racks let technicians swap boxes in minutes rather than debug in the field. Counter-UAS and top attack defense are design requirements, not bolt-ons. Both families plan for roof arc protection. lattice and narrow modules, spaced armor, and APS interceptors oriented skyward, panoramic EO and acoustic arrays that cue programmable HE and dedicated anti-drone rounds, and RF detectors, jammers to break control links. In the electromagnetic spectrum, filtered power, shielded harnesses, and tempest-aware layouts reduce vulnerability to interference while preserving radio performance. Doctrine changes when brigades can recompose quickly. A mountain task group pairs lighter kit FRCVs for direct fire with FICVs that deliver dismounts onto spurs, while loitering munitions and rockets take depth targets. In the desert, heavy kit FRCVs form the punch, with FICVs weaving between to clear AT teams, mark lanes, and secure strongpoints. In counter-infiltration, FICV sensor variants and remote weapon stations dominate night routes, while gun tanks remain in quick reaction reserve. Because electronics and BMS are common, every subunit shares the same map, IDs, and fire grids. Make in India economics aim for sovereignty and sustainment. Indigenous armor modules, sights, computers, and APS elements reduce external bottlenecks. AS9100 NADCAP-compliant MSMEs feed wiring, machine parts, and composites, and digital twins link factory jigs to field failures for rapid corrective action. Condition-based maintenance using vibration, temperature, and oil debris sensors triggers swaps before faults strand vehicles at a pass. Ammunition lines for APFSDS, MPAT, Airburst, and ATGMs scale with demand and upgrades without rewriting interfaces. Limits and counters deserve honesty. Heavier protection stresses bridges and roads. APS magazines are finite under saturation. Drone swarms evolve quickly, and EW can bite careless networks. The mitigation is training and discipline, route reconnaissance and engineer prep, fire control prioritization for APS, layered CUAS with deception and mobility, EMCON and wired backups for BMS, and rehearsed recovery drills that keep columns moving when one hull falters. Strategically, FICV and FRCV are less about replacing two legacy platforms than about fielding a coherent, upgradable armor ecosystem. If executed with realistic weights, robust electronics, and strong sustainment, India gains brigades that configure to terrain and threat in days, not months, and an industrial base that can spiral improvements on its own timeline. For deep dives on armored modularity, active protection, and India's path to a sovereign, upgradable ground combat fleet, visit globalinfoveda.com.